Hello, my name is Shashank Shekhar, and we have started the first chapter of Class 11 Chemistry, that is Basic Concepts of Chemistry. So, in the previous lecture, we discussed about the uncertainty in measurement. So, whenever we do a measurement, there is some sort of uncertainty in it. Regarding that, we discussed further about the significant figure. Okay, the first thing we discussed was the significant figure. What is significant figure? So significant figure is important because it is helpful in precising values. How do we do this? Okay. So there were certain rules. I will remind you all of that. So suppose I will illustrate you using some example. Okay. So first one was that all non-zero digits are significant figures. Okay. Suppose this is the number. Okay. So there are three significant figure. Absolutely. Because this all three are non-zero digits. Okay. Then 0 between two non-zero digits are always significant. So suppose this is the number. So there are three significant figures in this. Then the 0 after the decimal place means suppose the number is this. Okay. So it will have four significant figure. How? 1, 2, 3 and 4. Because this 0 is after the decimal. So four significant figure. And since this 0 is between two significant figures, so it is also a significant figure. Whereas a number such as 330 will have two significant figure. Okay. Now the 0 before the first non-zero digit. Okay. Suppose this is the number. So this 0 is before the first non-zero digit. 2 is the first non-zero digit. So it will not be significant. So there will be three significant figures. I am denoting significant with SF. Okay. In previous class also I have done this. The last one was that counting number like 23 balls or 3 tables will have infinite number of significant figure. Why? Because suppose this is the number of balls, I can put infinite zeros and it will be equals to the 23. So that value does not changes. So it will have infinite number of significant figure. Next thing that we have discussed was rounding off. So certain rules are important regarding rounding off. Those are that if a number, so suppose we have to round off this number one digit after the decimal place. So this is the decimal, so one digit will be 5. So if this number, the just preceding number, okay, is less than 5, then we will not change the number as a whole. Just drop off the last digit and we will write it as 23.5. Whereas if the number is greater than 5, suppose the number is this. So this is the we have to round off first digit after the decimal. Now since this number, just the number after the preceding number, it is greater than 5. It is greater than 5. So we will increase this number by +1 and drop this number off. Okay, so it will be 23.6. Now what happens when the number is you are dropping? The number after that is equals to 5. So suppose this number is equals to 5. Okay, 5. So we will see this number. Okay, the last digit which will be remaining after dropping off the digits that we are rounding off. We will see this number. If it is odd, then we will add it by 1 plus 1. We will add here +1 at 23.2. Okay. Now suppose this number is even. Okay. We will not do anything. Okay. We will just drop off the number. So this number is even and this is equals to 5. So we will just write this at same. Okay. It will be 23.4. Then we studied about the unit factor. how to convert in the dimensional analysis, how to convert from one unit to another, the important unit which you need in that experiment or in that calculation. So I will discuss it using an example later on in the next slide. Okay. Then we studied various laws. The first one was law of conservation of mass. Law of conservation of. Okay. So it says that in a chemical reaction, the mass is conserved. Means if 2 gram of something react with 2 gram of something else, then the result will be always 4 gram. Not greater than 4 gram or not less than 4 gram. So the mass is conserved. Next was law of definite proportion. Okay. Law of definite proportion. So what does it say? It says that whenever a compound is formed, the masses in which it combined is always fixed. The ratio of that masses in which it combined is always fixed. So suppose a compound is AB. So if this compound is formed by adding 4 gram of, means the amount of A present is 4 gram and the B which is present is 8 gram. So what will be the ratio? It will be 4 by 8. 4 by 8, so 1:2. So this ratio will be fixed. This was the law of definite proportion. The next one is law of multiple proportion. Multiple proportion. Okay. So suppose A and B reacts to form AB. Okay. Now it reacts to form another compound which is A2B2. Now, if they react, suppose it is reacting and the amount of A which is used is 2 and the amount of B which is used 2 gram, it is 3 gram. Now suppose the amount of A2 which we are reacting, it is 4 gram and B2 is 9 gram. Okay, sorry, 9 gram. So this ratio, the ratio between these two, is the ratio of B in the first compound to the ratio of B in the second compound, the mass ratio, ratio of mass 3 by 9. It will always be a whole number, 1:3 or 2:, or it can be for other compound, it can be 2:3 or it can be 1:2. For the compound, for this compound is 1:3, that is accurate. Okay, this is a hypothetical example. Okay, it can be 2:3. It can never be a fraction or a decimal. Okay. The next law is Gay-Lussac's law. Gay-Lussac's law. So what does it say? It says that in a chemical reaction, suppose the reactant, both the reactants are gas. So the volume with which they will react, the volume of both the reactant will have the ratio that will be a whole number. So suppose 1 liter of some gas A react with 2 liter of some gas B. So this will be 1:2. So its ratio will be a whole number. The last law is Avogadro's law. Avogadro's law. So what does it say? It says that equal volume of gas, equal volume of gas at same temperature and same pressure will contain the same number of molecules. Means suppose 1 liter of nitrogen, if it contains A molecules, okay, and 1 liter of oxygen, if it contains B molecule, then A will be always equals to B. But the temperature and pressure for both the volume should be constant. Okay. So this is the thing. Now, here is the example which I have said that I will discuss it. Okay. So this is the example of a unit factor conversion. Okay. So I am converting this 2 days. Okay. 2 days into seconds. So first I will convert these days into hours. So 1 hour equals to, 24 hours is equals to 1 day. Okay. I can just pass the numerator here. So I can write further that 24 hours is equals to 1 day. By 1 day is equals to 1. So this is the unit factor which will multiply. Okay. It will be always also equals to 1 days by 24 hours. So I will multiply by this so it can get cancelled. Days and days. I've said it earlier. It is not literal. It is just for keeping in mind. Just a way to keep the thing in mind. Okay. 24 hours by 1 day. We'll multiply it by 2 days. Okay. So this day and day will get cancelled. We will get here 48 hours. So first we had converted into hours. Now we know that 1 hour is equals to 3600 seconds. Okay. 1 hour. 3600 seconds. So again we will bring this numerator down. 3600 seconds is equals to 1 is equals to 3600 seconds by 1 hour. Now you see here, you have two options. You can multiply it by this or multiply it by this. So you will see that which I have to convert from hour to second. So I have to keep the hour thing down. So I will multiply with this unit factor. Okay. So 48 into 1 by 3600. This will be hour. This will be hour. Sorry. It is 3600 second by 1 hour. Okay. I'll multiply it. And whatever the result you get, this value is your required seconds. Hope so you have found the right answer. Okay, this is the answer. After multiplying this, you will get your answer. Now we will move to today's lecture. So in our first topic, we will discuss about the Dalton's atomic theory. Okay. Remember, I mentioned the Dalton's atomic theory while we were discussing the history of India and its intervention with science. Okay, Indian culture and intervention with science. So while discussing that, we have discussed about this atomic theory. Means I mentioned this word. Okay, so I will discuss it briefly here and how this thing came and which year it was developed. So that the idea that the matter is composed of small indivisible means which cannot be divided. Okay, something which cannot be divided. It is called indivisible. Okay, so any matter is made up of a small indivisible particle called atomium. Okay, so it is according to the Greek philosopher Democritus. And it was done between 460 to 370 BC. So the concept of indivisible atom gained renewed attention through certain experimental studies, which were done by some of those were done by Dalton. Okay, so in 1808, John Dalton, okay, he developed a new system of chemical physics, chemical philosophy. Okay. So what does it say? The first one was that matter is composed of small undivisible atoms. Okay, this thing is called atom, something called atom, which cannot be divided further. Okay, and atom of same element have same property. Means suppose I have an atom of iron, say it A, and another atom of iron, can say it B. So A will be equivalent to B. Means all the properties regarding mass or chemical properties or physical properties all will be same. Now, suppose we have a different atom. Suppose it is C. Okay, and it is an atom of carbon. Okay, it is an atom of carbon. So this atom C and this atom A will not be equivalent. Okay, I will put here a non-equivalent sign. Okay, they will not be equivalent. Okay, now compounds, how are compounds formed? So compound is formed when this atom A or this atom C or any other atom combined in a fixed ratio. Okay, in a fixed ratio to form a different thing that will be called as compound. So suppose two atoms of hydrogen will react with one atom of oxygen to give one molecule of compound water. Okay, so this is the thing. Now, what is chemical? He defined also chemical reaction as it is the reorganization of atoms. So atoms reorganizes. Okay, you will see in the later chapter that the shape of the molecule which is formed is different. So suppose it can be linear. Okay, two atoms are present here. It can be trigonal like this. So the atoms rearranges to form this thing called compound. Okay, and this is the law of conservation of mass. You can compare it to that, as mass is not changing, so neither will be the atoms are created or not destroyed during a chemical reaction. Okay, so Dalton was successful in explaining the chemical reaction or the laws of chemical combination. Okay, but he could not explain the law of gaseous volumes. Okay, so he could not explain the law of gaseous volume, that why atoms combine. And later on some laws came which were used to define it. The modern one which is existing is the quantum, and it is used to describe each and every reaction properly using dynamics. Okay, so that is the advanced topic. We will keep our discussion to this Daltonomic theory for this chapter. Okay, now moving on to atomic and molecular masses. Okay, so what is atomic mass? So you know that atom is a very small entity. You cannot define it always. It is difficult to define it. Modern technique like mass spectrometer enable this determination, but you cannot do it all the time. Okay, so in the 19th century, scientists do determine the atomic masses. Okay, but it was not significant, and it contains lot of digits. So we have to put some standards so that our calculation can be easier as compared to the atomic mass which we deal with. So initially, one atomic mass unit was defined, but before that, a hydrogen was considered to be one of unit 1. Okay, so it was said that okay, one lightest atom, it is the lightest atom, so 1 unit of hydrogen. Okay, this was taken as the standard. Sorry, so this was taken as a standard. Now, the current system which was established in 1961 says that carbon-12 was taken as the standard thing. Okay, and it was called atomic mass unit or AMU. So what is AMU? AMU is 1/12 the mass of a carbon-12 atom. So scientists first measured the mass of a carbon-12 atom using mass spectrometer. Okay, mass spectrometer, and then they took the 1/12 of its mass, 1/12 of its mass, and they describe it as 1 atomic unit or 1 AMU. So this calculation is shown here. Okay, so this is the thing they have done. Okay, so suppose you have to calculate the mass of a hydrogen atom. So what is the mass of the hydrogen atom? You can do it here. So this is the mass in terms of AMU you have to calculate. Okay, so first we will know the mass of the hydrogen atom using mass spectrometer. This is the mass, and then we will divide it with this. This is 1 AMU. Okay, so it comes out to be 1.0080 after rounding off. So the thing rounding off is done here also. Similarly, if you have to calculate the mass of an oxygen atom, you can do the same. You will take the mass of one carbon atom, oxygen atom. For reference, so this was the mass which came out. When we divide 1/12 with the mass of the carbon atom, then this is the value we get. So this is 1 AMU. So using unitary method, we have to get the atomic mass unit. We will simply divide it with 1.66056 into 10 to the power minus 24 gram. So you will get the AMU. Okay. The unit atomic mass was then replaced by, later on it was replaced by U. And so instead of writing here 15.995 AMU or approximately 16 AMU, we can write it as 16 U. So when performing calculation involving atomic mass, average atomic mass are typically used. Okay. So what is average atomic mass? So in nature, whenever we see things, we see different atoms, they are not as singular, but many entities are present. They are identical, will have different chemical properties, but we will give the same name, and those things are called isotopes. Okay. So you will discuss this in detail in the latter chapter, but for a reference, I am saying that suppose it is a carbon, there is a carbon atom. So carbon atom is not that carbon element which you are seeing with the carbon thing does not contain only C12. It can contain C14. So this thing C14, C12, this is the mass number, and it represents the number of proton plus the number of neutron. Okay, and the number of neutron varies from one carbon isotope to another carbon isotope. Okay, so there are other isotopes of carbon. Similarly, there are isotopes of chlorine also, and many more elements have different number of isotopes. So we calculate the average atomic mass for our reference, but not the actual atomic mass. Okay, so we calculate the average atomic mass. For that, we have to know the relative abundance of each of those isotopes in the nature, and that should be present in percentage amount. Okay, so how do we do that? So for that, we do that thing is called this is the formula. So let us take an example to do this. Okay, so I am taking the carbon atom for doing this. I have discussed it earlier that is many isotopes. Okay, so how I will do it? So suppose this is the relative abundance of 12U. Okay, this is the relative abundance of 13U, and this is the relative abundance of 14U. Okay, so simply we will multiply those abundances with their atomic mass unit or AMU and sum it. Then we will get the atomic mass unit and average atomic mass unit of carbon. It comes out to be 12.011 atomic unit. Okay, so you can summarize this formula as this. Okay, so suppose I am representing the relative abundance with A. So AI, and this is the atomic mass unit of, this is I, and I goes from 1 to the number of isotopes. Okay, so using this formula, we can calculate the average atomic mass. Now, we will move to the molecular mass. Okay, so what is molecular mass? So molecular mass is calculated by adding the atomic mass of the individual element present in the molecule. You will see an example to do so. So what is done? So suppose consider a molecule, then it will have different number of atoms. So we will add simply the mass of that atom and we will get the molecular mass. Okay, now further we will multiply that atomic mass unit with the number of atoms present. Okay, so let us first, for example, let us calculate the molecular mass of methane, that is CH4. So how you will do it? So this is the atomic mass. What is the number of carbon atom present? It is 1. And number of hydrogen atom? It is 4. From data we know that the average atomic mass, I will use this term average atomic mass each time. Okay, so because we are using the average atomic, not the actual, because of the isotope present. So this is the average atomic mass of carbon. Okay, we will add it, multiply it by 1. I have not written it here. It is just usual. Okay, now the average atomic mass of hydrogen is 1.008. We will multiply it by 4 because the number of hydrogen atom is 4, and then we will sum it and we will get our result. Okay, similarly we can do it for the water molecule also. So suppose, so the atomic mass, average atomic mass of hydrogen is 1.008, and the number of hydrogen atom present is 2. So we will multiply it by 2. Now for oxygen atom, it is 16.00 U, and we will multiply the number of oxygen atom, it is 1. So we will get the whole as 18.02 atomic mass unit. Now moving up to the new thing that is called formula mass. So we have discussed about the atomic mass unit, then we have discussed the molecular mass. Now we will move to formula mass. So what for solid substances like NaCl, molecular mass term is not significant or not good, you can say. So for those things, because they are present as ionic form, okay, and there is a 3-dimensional structure. You will see the structure later. So in compound like NaCl, it is important to highlight the arrangement of ion. Okay, there is a crystal lattice. So crystal lattice is a type of 3D arrangement. Okay, for solids there are 3D arrangement and not molecules are present. Okay, so within this structure, each sodium atom, for sodium chloride I am telling, for each sodium atom is surrounded by 6 chloride ion. Okay, then and vice versa, means each chlorine atom is surrounded by 6 sodium ion, and each sodium ion is surrounded by 6 chloride ions. Okay, now this arrangement plays a crucial role in the property and behavior of ionic compounds. So ionic compounds and covalent compound, these are 2 types of compound. So NaCl type of ionic compound, and they exist as solid, and there is a 3-dimensional structure of that solid. Okay, it is important to note that when we refer to formula mass such as NaCl, it is used to calculate the formula mass. Okay, formula. Okay, so it is the formula mass, not the molecular mass. So why it is done so? Because you can see here a diagram of NaCl structure. You can see it is not present as a molecule but as a crystal structure. Okay, it is a crystal structure. It is a 3D arrangement of sodium chloride, where each chloride ion is surrounded by 6 sodium ion, and each sodium ion is surrounded by 6 chloride ion, and 3-dimensional structure and not a molecule. So we calculate their formula mass and not the molecular mass. How do we calculate the formula mass for NaCl? It is same as the molecular mass. We are just changing the name because it will look more significant for that proper compound. Okay, because it does not exist as molecule but as a crystal structure. Okay, so what is the mass of sodium atom? So the mass of sodium atom is 23.0 U, or atomic mass unit, and the mass of chlorine ion is 35.5 atomic unit. They both are the average atomic mass unit. Okay, so we will add this and multiply it by 1 because 1 sodium atom is present and 1 chloride ion is present, and we will get it as 58.5 atomic unit. The next thing, we will move to the mole concept. Okay, move to the mole concept. Now, when we are dealing with atoms and molecules, suppose we take 1 gram of something like iron or copper or some matter, then it will contain a large number of molecules. But we, in some experiments, we need to quantify that number. Okay, but it is not possible to do so because that number is too large. Okay, so for that we need some convenient magnitude so that we can deal with that large number. Similar to, like, if you are thinking about you go to a shop, then you say that, okay, give me 1 dozen of banana. So this dozen thing is the type of magnitude or a standard which we use to make our daily life easier. Similarly, when we say a score, it means 20 entities of that. When we say it gross, we say it 144 entities. And similarly, in science, we have this mole thing. Okay, this is mole. What is mole? We will discuss this later. So it is a type of quantifying standard used to count those microscopic entities. So these entities can be atoms, can be molecules, then be particle, electron, ion, and anything. So 1 dozen can be anything. It can be banana. It can be apple. Okay, it can be anything. Similarly, this 1 mole can be any entity. Okay, so in SI unit, the mole is introduced as a 7 base unit. So I have studied, you have studied about the base unit, which were kilogram for mass, and candela for luminous intensity, meter for length, second for time, and there were many more, 2 or 3 more. So similarly, for counting the number of substances, we have this mole thing. Okay, so the mole is used. So the symbol mole, it allows scientists to work with the immense number of particles. Okay, I said it earlier that if you take 1 gram of some matter, then it will contain a large number of molecules. You cannot imagine it, and it will cause difficulty in calculation. So to make this scientific calculation easier, which involve atomic and molecular calculation, you will need this thing called mole. The mole is represented by this MOL. Okay, and what is the definition for 1 mole? So 1 mole is exactly 6.022140076 into 10 to the power 23 entities. So if you are saying that, suppose if you are saying that, okay, 1 mole of electron. So how many number of electron will be 1 mole of electron? It will be 6.022140076 into 10 to the power 23 number of electron. Similarly, for 1 mole of atom, there will be 6.022140076 into 10 to the power 23 atoms. Okay, so this number is fixed and it is called as Avogadro constant. Okay, or Avogadro number, and it is represented by Na, where A is in subscript, and its unit is unit per mole. Unit here represent that, okay, you are saying that electron, so this amount of electron per mole, so this amount of atoms per mole, or this amount of molecules per mole. Okay, the term amount of substance represents N. Okay, this N can be anything. I said it earlier, it can be atom, it can be molecule, it can be ion, it can be electron, or any other specified particle or group of particle. So next, it is essential to understand that regardless of the substance in question, yes, it is important. You will get confused that why it is using for another thing. Means teacher will usually use it for atoms, okay, that it is number of atoms, but you can use it for anything. So it is a generalized concept, so you can use it everywhere. This Avogadro principle, that it contains 6.022 into 10 to the power 23 entities. Okay, how does this number was established? How this number was established? Okay, so this was the mass of a carbon 12. So for this, the mass of a carbon 12 atom was determined using a microspectrometer, and it was found to be 1.992648 in 10 to the power minus 23. Now this number is used to calculate. So this is the mass gram of a carbon 12 atom. It can be written. Okay, so how it was calculated? So it was calculated by using this formula. Okay, so it is 12 gram. This is the mass of that 12 gram, one atom of a 12 gram atom. This gram will get cancel. This carbon atom will go up, and this mole of carbon 12 will go down. We will get this. So why it is written here 12 gram per mole of a carbon 12 atom? Because 1 mole of carbon will contain 12 gram of carbon. Okay, 12 gram of carbon. So this is used as a standard. Okay. So you can say it in mathematical term as 12 gram per mole of a carbon 12 atom. Then we multiply it with the mass of one atom of a carbon 12 atom. So we'll get this number, which is called Avogadro constant, and it is denoted by Na, which comes out to be 6.022 into 10 to the power 23 atoms per mole. Okay, I will not use this number each and every time. You can round off this to 6.022, and the scientific calculation also, in the later on chapters also, that will be round out. This round off thing will be used everywhere. Okay, so you can use it independently. Okay, the same thing is written here, that the amount is called the Avogadro constant, okay, or the Avogadro number, and it is denoted by Na. So why it was named? It was named in the honor of a scientist named as Amadev Avogadro. Now you must have seen that we are writing it here using a scientific notation. I have told it earlier we have studied earlier about the scientific notation. So this is the enormity of the number of atoms. Okay, so you can see that how large number of digits are used here to do this. So you can you may just imagine the difficulty if we use this thing. Okay, now coming to this, yes, one more thing. Yes, that you can convert this number into scientific notation. If you want to, you can do this. It will be an exercise for you. Okay, for converting the number into scientific notation. You can see it as the utility of scientific notation. Okay, as a result, we can use this entity Na in different forms, like 1 mole of hydrogen atom, 1 mole of water atom, and 1 mole of sodium chloride. So each of these entities, hydrogen atom, it will be 6.02 10 to the power 23, or a water molecule, it will be 6.02 10 to the power 23. You can see here I have used top of the remaining digits, which was 14677, to make it more easier. It is called rounding off. You have seen it earlier. Similarly, 1 mole of sodium chloride includes 6.0223 formula units of sodium chloride. Why we are saying formula unit and not molecules? Because it is a 3D arrangement. Okay, 3D arrangement of atoms. Sodium chloride is a 3D arrangement because it is a solid, so it will be a 3D arrangement of atoms of sodium and chlorine. Okay. With the concept of the mole, it becomes easier to determine the mass of 1 mole of a substance. So we can use it in the scientific calculation. Okay. Now, the mass of 1 mole of a substance expressed in grams is referred to as molar mass. So this thing is this new concept, molar mass. Okay. So what is molar mass? So suppose you are given a compound and you are said that suppose it is 13 gram of that substance you are taking. 13 gram of that substance. And you are said to calculate the number of moles. So how you will do it? It is simple. You will use the symmetry method. So for that, first we have to know that what is the molar mass of that substance. So molar mass of a substance, you can define it in this way, that molar mass of the substance is the amount of substance which contain the Avogadro number of that substance. So it is called molar mass. Okay. So what you will do to calculate the number of moles, I will discuss this number of mole the later chapter discussion also. So for that, I'm just giving a brief content so you can get some idea about this mole thing. Suppose this is the given mass, and you divide it by molar mass, and also to see the utility of molar mass. And what is molar mass? It is the amount of substance which contain the Avogadro number of that substance, and by dividing this you will get a mole. It is represented by mol. Okay. So for example, the molar mass of water is 18.0202 gram, and it will contain 6.022 into 10 to the power 23 number of water molecules. Okay. Similarly, sodium chloride is 58.5 gram per mole. Okay, thank you.